Can you start from the first screen?
Can everyone see my screen? Hello.
Yes, we can.
So, my name is Maya Waomotunde. I'll be presenting for the customer segmentation group. So these are table of content. This is the way the first talk about the concept of customer segmentation, the aim of the project, the methods we used. Then we'll describe our data set, our findings, the challenges we encountered, and the conclusions. So about customer segmentation is the process of grouping customers based on what they have in common, be their demography, their location, their pattern of spending, the kind of products they purchase the most, and their psychography. With customer segmentations, business can be able to improve on their products based on the findings they get, able to improve their products, know the kind of messages they will pass to their customers, and in some cases, they might be able to predict the purchases of their customers. So the aim of our project now is to be able to, from our project, we're asked to analyze the data sets from an e-commerce store over a period of 1 year. And then based on these results, to be able to determine their purchase for the next year. Then we use these are the methods we used to carry out the project. We visualized the data, then found out the inconsistent data, the data set that needed cleaning. Then we used RFM analysis to analyze how frequently they bought what they purchased, how recent their purchase was, and their monetary value, how much they are worth. So RFM stands for recency, frequency, and monetary value. So with RFM, we're able to determine how loyal these customers were. Then we also use K-means algorithm. With K-means algorithm, we're able to group the customers into clusters, and from these clusters, we're able to find out the products they consumed the most. Then we also visualized and interpreted our results. So these are the description of the data set that we're provided with. Then when we explored our data, we found out that there were some missing data sets in the customer and description column. Then we tried to visualize if we could be able to impute this data. But from the information we were given, we're not able to impute it, and customer ID had the largest number of missing values. So we had to remove them because we're not able to use this data set and it will affect our data. Then we also explored our data further and found out that the United Kingdom had the most amount of customers, and they bought the highest number of orders. So After cleaning our data, we decided to use RFM analysis to compute the RFM values of each of the customers. Then we use quarter to group to find out. We also use quarter to find out the RFM scores of each of these customers. And um, from this quarter, we're able to 1114, like here now, 1114 represents their value to their RFM score value. So for a value like 111, those are the best customers of the e-commerce store. The first one represents the R. That means they are the least. They were the ones that bought the most recent, and they bought more frequently, and they had the high monetary value compared to the others. For those that had the RFM score of 414, for example, now the 4 represent that it had been a while they purchased last, though they purchased frequently, and they also didn't have high monetary value. Then we also used K-means clustering to cluster the customers into groups. To do that, we first standardize the data using standard scalar. Then we use SILAE to find the mean distance between each clusters and the mean nearest cluster distance. So with K-means cluster, we're able to find the number of customers per cluster. With that, we're able to know which customers are more valuable and how the e-commerce store will target their promotion and marketing strategy. Then we use TSNE to visualize the clustering. From the results we got, we're able to determine the mean basket price, the minimum basket price, the maximum basket price, the quantity of products purchased by each customer, the unit price, the list unit price. We also found out the number of cancelled orders. So we removed those ones. This was part of the data we cleaned. The total amount spent by each customer, how frequent they purchased, the top 10 products bought based on each clustering. So with the top 10 products bought, the e-commerce will be able to predict the kind of purchases each group will make for the following year. These are clusters. From the cluster, we're also able to determine the frequency. As I've explained before, the frequency each clusters made their purchases. That's it on that. Then some of the challenges we experienced were cleaning our data because there were inconsistencies in the data. We had to make sure that they were thoroughly cleaned and removed duplicate values. Then it was also difficult for the group to understand the kind of algorithms to use. And then some of our codes were very slow in running, that we had to start. Then we're not able to get some of our results. Then we had to do it multiple times to be able to get our results. Then also interpretation of our results. We also have challenges in interpreting our results. Based on the RFM analysis and K-means algorithm, we're able to group our customers into clusters and find out the top product that were bought by each group. That's it. Hello.
Yeah, we can hear you. Thank you. That was a nice presentation. Okay, George, do you have anything to say? Contribution?
Well, I think I have a question.
Okay.
This is a question. Okay, what's the name of the presenter, please?
I didn't get it.
What's your name, please?
Mayowa.
Mayowa. So I have a question. If I should give you the gender like as an extra feature, if I should give you the race as an extra feature, are you going to use it? If I give you like, let's say we have like extra features, let's say we have like from the features you have so far, you have order, you have quantity. Let's assume that I give you like gender and I give you like race, like extra features. Like, are you going to use those features?
Am I going to use them?
Yeah. Does adding those features will it make your model perform, or will it make, like, is it going to make your whatever metric you are using? Is it going to improve the metric you are using?
The previous data sets we were given, we had gender, and we're able to use it to predict. We're able to use it to cluster our customers into groups with that.
So my question is this: okay, by having gender, let's stick with gender and race. By having both of them, is more or less like you're introducing like a bias. Yeah. So it's more or less like your model might be might be sensitive to a particular maybe race or maybe a particular gender. Like, the reason I actually ask this question is that sometimes there are some features you drop, like you take them out. You don't want your model to infer those kind of features. Like, you just take them out because you want something that will work well across all board. You don't want a model that is sensitive to a particular race. You don't want a model that is sensitive to a particular gender. So like, that's just like, this might not be like a big thing out there, but recently a lot of things have been happening in interpretable model with respect to like fairness in AI. So sometimes a client might give you a project, and one thing you should do is, you as a machine learning engineer or a data scientist, and one thing you should always do is you should think about the ethical part of your model. Okay, I'm going to drop this gender, I'm going to drop this race, I'm going to drop some other features because I have a reason. It is like an obligation. Forget about what is behind, but this is something that I think I've worked on something like this before. So there were questions like this we got to ask, and it was like a big deal. So going back to what you did, I think is actually a good one. But the reason I just had to like go back and ask you that question. I don't even know why I had to go back and ask, but I think it's a very
also
big...
use correlation map to see if the gender would have any.
Yeah, you can actually do that, but it's always advisable to drop features like that. Like, it is always advisable to just take them out if you don't want to kind of introduce like a form of bias. And another question is, why do we have UK as the most most items are being bought from people from the UK?
I didn't get that.
Why do you have, there's a particular chart you had, there was UK there. I can't remember what the UK, like, you had more items from UK, or most people bought items from UK. I don't understand that chart.
I don't.
There's a chart, there is a particular chart you had, there's a particular table there's like an outlier. The UK, they have like a lot of people from the UK as an outlier.
Yeah.
So did you ask like what was the reason why you have a lot of people from the UK as outlier? Is it that they had more stores in the UK, or like what was the reason why you had a lot of?
It's an e-commerce store. Why I don't
Okay.
really know that from the data. I couldn't get that.
Okay. So what did you do about that? Did you take them out, or how did you solve that
We
problem?
didn't take them out. It could still be of, I don't know, people probably their target audience would have been from the UK.
Okay.
I don't
Yeah.
think it will make
Yeah.
sense to remove them from the,
Yeah.
from
Okay.
the data set.
And one last okay. I don't think I wanted to ask about the top top product, but I think you already answered that question. So for me, it's actually a good presentation. And did you do about your did you do cross validation?
I didn't get that.
Like I was thinking about cross validation and other stuff, but no, you're not doing a supervised learning stuff. So all right, for me, it was actually a good one, and I don't know, like I was just thinking about something else. I was thinking about like the biases. I wasn't even thinking about, but I think it was actually a good one. The problem is when it comes to this RFM analysis, sometimes interpretability is always a big problem. Like interpreting them is always a big problem. But I think playing with the data, understanding the kind of customers you have, like I'm talking about if you should go to each cluster, you know what is common among those clusters. Like it makes sense to look at it from that point of view than just having them than just clustering them and saying that, oh, these things are important, these things are important. Like try to know like why is your algorithm clustering them. Like it makes sense for you to understand like the underlying relationship among each cluster. But for me, it's a good one. It's a good intro to RFM and a good review for RFM for me. Yeah.
Are there any algorithms you suggest that could be used for this kind of thing?
I can't really remember, but most times they use RFM. Like most times they use RFM. Like that is what they use. Most times they use RFM. Yeah.
Okay, thank you, George. Okay, I just noticed Kelechi is on the call. Welcome, Kelechi. You are going to be giving contributions soon. Adirayo, do you want to give any contribution? Adirayo, is there anything you want?
No, I'm just observing.
Oh, okay.
Yeah.
Udeme.
Yeah. So nice one, actually, nice presentation. Because I just did something, I think like a couple of months back on segmentation, and I actually had to use RFM, and which was quite, and what you just did kind of reminded me of what I did, which is quite interesting. But yeah, I didn't get the part, like how many clusters were you able to
Like
come up with, and how were you able to select the number of clusters?
I used k-means clustering.
Yeah.
I use k-means algorithm to cluster them into groups.
Yeah, like can you go back to like those your clustering slide? Okay. Yeah, so can you go like to the next one? Nope, where you had like the number of clusters. Yeah, I mean like great. So from here, I mean it looks like bulk of your customers are in one cluster.
Yes.
Right. So
Yes.
like My question would be, don't you think that so I don't know the thresholds that you use for each of them, but it's very likely like more than 50% of your customers are like in one cluster, and there might be something peculiar to that cluster that you might also want to pay attention to, because for me, it looks like these other ones are like very, these clusters with fewer numbers, like this cluster 7.
Yeah.
It looks very weird. So I think, I mean, when you're trying to cluster, like Georgia said, it's not just about knowing, okay, this. It's also about having like, how do I put it? Like having an idea of like customer personas. Like you know what each customer is, or you kind of have like a rough persona of the person that are involved in each cluster. And this cluster that has like bulk of your customers might kind of make whatever model kind of feel like a little bit skewed already, because I mean from this
One of
now.
the factors, with the majority of the orders were placed from the United Kingdom. They had the most orders purchased.
Okay. So that means probably like location actually played like a very huge.
Yes.
Yeah, so like George also said, in trying to, avoid some kind of bias, you can see like location now. If location was actually like the primary factor to having like most of your clusters or most of the customers into one particular cluster, you might also want to see how the clustering would perform if you take away location. Because location, yeah, it matters, like it affects where you are, could actually determine why you're using a particular product. But since you're trying to do like a very baseline or generalized clustering, you might
Even,
want.
sorry to cut it short,
Yeah, go ahead.
aside removing the location, there are also some other determinants like the quantity purchased. They will still refer back to those people in those residents, like in terms of location. They had the highest number of purchase, so it will still point back to location. Those in the UK. I don't know if you
Yeah,
get what I'm saying.
yeah. I get what you mean. Like, obviously, I understand. I mean, most of the purchases will still be from people in the UK, which is totally fine. But I think also having like a variable that specifically states the location, like UK, like it might kind of make your model a bit biased. I mean, the transaction volume can vary based on different places, but if you have like a very strong indicator that shows that, okay, most of these transactions are like UK might, and like I'm just trying to think in ways to try to make your model more generalized than being a little bit biased. Do you get?
Okay. Yeah.
Yeah, and then the presentation, it's quite detailed, very much interesting. It's just that when you started presenting, I was like, okay, I was a little bit, your choices of color was a little bit funny, and some images, like I kind of had like some kind of color bias between your background and some of the images. Yeah, so I mean, obviously, data communication is like another way of selling your market. So if you want to do, just an advice though, like presentations like this, you might also want to take our time to not make your audience miss out on the point by focusing on some other things that don't matter. Because that was the first thing that came to mind. Like if you go to, there's a particular slide that you had like a graph that showed the different clusters or something.
Yeah.
Yeah, like I'm like, this is the presentation itself, like the colors too. You might also want to pay attention to that because you want the people to get, I mean, the work that you did, and you don't want them to lose focus on that by, paying attention to some other things. Yeah, but all the same, well done. Well done to you and your team.
Thank you very much.
Okay. Thank you, Dome. Teju, do you want to say something? Kelechi?
No, that was a Good presentation. Well done.
Thank you.
Pretty much everything has been said. I hope you take the feedback and continue to improve on yourself. And welcome to the team, to your team.
Thank you.
Okay, Kelechi, do you have anything to say? Yeah, Kelechi.
No, I think everything has been said. Udemy already mentioned the presentation bits. I think that's very important. Like for instance, the charts we are seeing on the screen. So George also mentioned the fairness part. So yeah, everything has been said. Good presentation, and kudos to the team.
Thank you.
Okay, thank you. Thank you, Mayowa. Yeah.
Thank you.
Okay. So the last thing, bicycle sharing. Is there anyone from the bicycle sharing team? That's Wale's team.